So now we want to work on the situation that we have like 2-level full factorial experiments. And in the previous example, it was general. So we had 2 factors, like multi-factor, 2 factors. One factor had 2 levels, another factor had 3 levels of the experiments. But here we want to generalize some equation. In principle, one can study factors at any number of levels. Levels need not to be equal. For example, we could have 2 times 3 times 6 times 4. However, 2-level factorial experiments are easier to design, analyze, and confound. In the next chapter, we would have more about that, and are therefore very popular and widely used. So for example, we would say 2 power k. You would see 2 power k a lot. That k is the number of the factors that we would have. In addition, recognize at the outset that the 2-level factorial experiments are really building blocks. It is often not sufficient to carry out one such experiment and then stop. Depends on the objective of the experiment, of course. Underlying the design is a linear model for like, so if I give you 2 power 3, is like that I have 3 factors like x1, x2, x3, and each of these factors, they have 2 levels, low and high, for example. If you see something like this, we can write it like this, like the general regression model, which has all of the factors and interactions. It would be like beta null, beta 1 x1, beta 2 x2, beta 3 x3, beta 4 x1, x2. So here, instead of beta 4, you can write down beta 1, 2 as well. So the way some books, the indices like that, they wouldn't write down like beta 4, beta 5. They would try to say that, okay, if I have x1 and x2, for beta, I would have 1, 2 as well, but it's okay. Both are acceptable. And then beta 5, x1, x3. So you see all of the interaction and then the 3 interactions. So in design of experiment, in the factorial one, what are we going to do is that when we have an ANOVA table, we are going to remove the ones that their interactions are very, like the F observed for them are very small. So we can remove it and we can have a smaller, like the regression model. So here you can have an example for yourself and work on it. For example, if I ask you, we want to have a model with 2 factors and each factor has 2 levels. If I ask you what would be the number of it, you would say that, okay, so it's going to be 2 power 2, right? And if it has the interaction, they don't have the interaction, so it will be like a surface like this. So these are the equations that I made it for you as a cheat sheet, but I will post it later. So it's going to be like this, and if they have the interaction, so you will see the curvature, right? Depending on how big is the interactions. Here are some considerations made between designing an experiment. So when you want to work on the design of experiment, try to answer these questions by yourself, like in the lab or outside. Say that, okay, what are the objectives? So what are you looking for? Are you looking to like think about the cost, everything that you have? Like, what are your main objectives here? Which variables, factors are to be studied? Try to have your factors, like main factors. What are the ranges? Like, what are the levels that you can have? What is the like standard deviation of the response measurement? Like, how accurate you want to measure it? So you want to go with the 2 decimals. You want to go with the 4 decimals. Like, it depends on the application that we have, right? Like, for example, in health sector, most of the time, like in pharmaceutical companies, most of the time we are going. It's very important for us to have like the to have more accurate responses, to collect more accurate responses. How many experiments can you afford? Like, let's say the number of all of those runs that you saw, like the replicates and runs that we have, all of them together represent the number of the experiments that you would need to do. Like, if you are giving me that, telling me that, okay, then I have like two factors, and each of them, like one has like 3 levels, the other one has 2 levels, each operating condition I want to have 3 replicates, meaning I would have 18 in total. So it's like that we have to be able to afford to have 18 experiments, like to run the experiments 18 times. If not, if I tell you that, okay, no, but we don't have enough money and time and people to run the experiments for us, especially time, it's very important here, because each time that you run the experiments is going to take time, right? And if you want to, you can say that, okay, we're going to do it at the same time. Yeah, be my guest, do that at the same time, but you would need more equipment for that. And it's not something that is going to happen in industrial application. Because of that, so we would go with the fractional factorial experiment. So I would say that, okay, so for example, my boss will tell me that, okay, Lena, stop it. You can have just 8 experiments. So I would make that half, like I would choose among them, or I would make the fractional one that we would have it later in the next chapter. All of the above questions are part of the brainstorming stage for prior knowledge build-up. And you want to do that. Here is the sequential design strategy. The basic problem of experimental design is deciding what pattern of design points will be most revealing. At the beginning of an experiment, when little is known, the question of which experiment should be conducted is difficult to answer, right? But it's the, like it's the circular dilemma, or dilemma. At any stage, the range of the variables might change. We might drop some variables, and we might add some variables. So there are many, consider this, that each stage that you're working in your design of experiment, there would be, even the objective might change. So we're going to quickly adapt ourselves with our experiment with the new situation that we have. Here is a 2-level factorial experiment. Here's an example. So example of the 2-factor design. Look at here, we have the experiment, like 1, 2, 3, 4. We have the temperature and some rate in RPM. So the temperature is 100 and 200, like low and high. And then the rate that we have is 500 and 1500. And we mix and match of that, like for each experiment we have, like experiment number 1 is going to be low level of temperature with low level of the rate. Experiment number 2 is going to be low level of the temperature with the high level of the rate. Number 3 is the high level of temperature, low level of the rate. And number 4 is that high level of temperature and high level of the rate. That was for 2-factor. For 3-factor design, we have like, we have temperature, rate, and catalyst type. So for the temperature, we would have, you can see that, again, I have like each of them, they have 2 levels. So it's like the first one was 2 power 2, the number of the experiment. And then the 3-factor design is like, this one is 2 power 3. It's like that I have 2 levels for each factor, but I have 3 factors. I have low level and high level of temperature, low and high again of the rate, and the 2 different types of the A and B, like catalyst type. So you can see that we have like 2 power 3 for this one. 2-factor design, we show it like this. And I asked you a question at the beginning of this chapter that, okay, so what about if we have more than 2 factors? What's going to be the shape? And you can see that here we have cubic when we have 3-factor designs. The way that we would read it, it's exactly the same way that we had before. It's like that you would have, like, for example, here you had the low and high, low and low, and then you would write down the response here, the value of the response here. Or here it would be high temperature, low rate, you're going to write down the response here. And here, when you want to read it, it's like this. You would need to look at what, like, look at it to see that which rate you have. Like you have low, high, low, for example. It's going to be one of these. So all of these situations, like experiments, can be shown here. If you have replicates, so you're going to, for example, if we had the replicates here, then we have low temperature and low rate. So I would have 2 numbers here next to each other. I would write down next to each other. So it would mean that I have replicates. We have the same things here. You could have like 3 numbers here, like 3 as replicates on one of these points, like corners. Look at here. This is the 2, we call it 2 by 3 sometimes as well while we are reading that, but it's 2 power 3 factors. And then I have the 3 factors, and my factors are like ABC. And when I want to have my design matrix, instead of low, I'm going to write down minus, and instead of high, I'm going to write down plus. So it's like -1 + 1, something like that. And then for each run, I'm going to have the combination of them. Like, for example, here is the geometric view. Then you can say that, okay, minus, minus, and B is minus here as well, right? So it's the minus, like in the, it depends on if you're in the, B is in the, no, B here is the -1 because here is the factor B. So we have to be very careful when you want to read it. Like, for example, number 1, which is the like in the, it's my origin in my, like all of these one, the geometric that I have. So 1 is the, I look at factor A is minus, factor C is minus, factor B is -2 because this is B, right? So it's the, like, whatever it's here, it's going to be minus, whatever is here, 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 and here, for B is going to be positive, like it's going to be high. So we would read it. So it's very important. So it's possible that in your quiz, I would ask you, I would give you something like this, and I would just ask you to give me the row, like from the design matrix. So we call this one design matrix. So later, if I ask you that in your design matrix, what's going to be the like signs for this point, like, then you would say, okay, you would say it's like that. Look at here, A here for this point. A is positive, right? C is positive as well. And then B is like negative because we are on this surface. Whatever you have on this surface, like on the front surface here and closer to me or closer to you from the screen, that surface, it's B is in the low one. So whatever you have on the back, so you can see that here on the back, that one B is high on the high level because here factor B is high and factor like B here is high, here is low. The way that we write it down here on the, when we want to transfer the positive and negative on the geometric view, is that when you have AC here, means that A and C are positive. The thing that is not written is negative. So that's the way that we would read it. So for example, if I ask you which part is 0.8, you can play with yourself and then you can ask me your question about it. It's super important that you could read these, transfer the geometric view to the design matrix in our course. Because later, when we want to calculate the effects, it's going to be much more easier. Like the time that when we said that in chapter 2, we said that let's learn the ANOVA table here once forever. Like when we go further, we are going to add a small portion to this. This one is the same. So we need to be be expert in reading these ones. I understand it's new, so because of that, we're going to do practice together. And in summary session, I'm going to practice on it as well. So it's like that. I would say, okay, so let's say I'm looking for this number 8. If I ask you to show me which of these corners are number 8, what would you say? Pause the video, try to find it by yourself, and then come and listen to the rest of it. And so what's going to happen is that for number 8, I would say I have positive, positive, positive. It's like that A, factor A, B, and C, all 3 of them, they're working on the high, the operating condition is that they're on the high level. So what I'm going to do is that I need to find the part that all these C, A, and B, all of them are on the positive side. So here, A, low, high, so it means that I have to be on this surface for A, right? And then factor C, low and high, it means that I have to be on this top surface to find out the C for the positive one. And then for B, it's like, so far I have this like surface that I have on the right, and then I have the surface on top, like if you look at this cubic. on top. So the first one is that represent that A is in high, and then the top one represent that C is in high. And for B, I would need to look at the surface that I have on the back, which is this one. And the back shows that, okay, so here B is high. And I'm looking for the part that A, B, and C, like these surfaces, their intersection, like intersection of the three surfaces is gonna be a point here, right? So this point here that is written ABC, it's gonna represent number 8. So when I give you question in the quiz, I won't write down this ABC for you. I would just give you a cubic, and I will write down, like I will give you low and high factor A, like these parts, low and high factor B, because if I give you ABC, so it's like that, we said that whenever it's positive, we're gonna have it on the geometric view, we'll write it down, so we will find it. Try to practice it. For example, randomly, I'm going to choose one more, and then I'm going to go to the next slide. So, for example, something, let's say 6. Run number 6 here is like that A is positive, B is negative, and C is positive. So what I'm going to do is that A is positive, so it's like that I'm looking for this surface, and then B is negative. It means that I'm looking at the front one, the one is closer to me, because B is negative. And then C is positive. It means that I'm looking for the top one, because C is here, is positive. So, and then I will look at what's the intersection between them. It's like that I'm looking for A and C, right? So it's going to be here. If you get this point, at this point, A is positive, right? C is positive as well, right? When you look at it. And then B is negative, because we said that whatever we have on this surface is there, represent the B, negative value for B, like them on the low level. Okay, so look at here. Here is the meaty part of our lecture. So we talked about that. We talked about that, how to read these geometric ones. Now we want to look at the main effects, 2-factor interactions, and 3-factor interactions. When we are talking about the main effect, for example, for A, positive of the A, and then negative of A, right? Or B, we said that this is the negative, this is the positive. So we get the average of this positive one minus the average of this negative one. Here again, for the main effect of B, the average effect of this positive one and the negative one of this one. It's going to be super easy if we go for finding out the effect, if you go with the geometric version. So it's gonna, but with the, you can go with the design metrics as well. And over time, I found that the amount of the type 1 mistakes that we do when we go with the geometric one, it's a lot less than the time that we go with the design matrix. The design matrix, it's good, but it comes from the geometric one. So if you, in the transferring from the geometric to design matrix, if you do a mistake, then all of your calculation is going to be wrong. Because with these effects, we are going to find out our beta, we are going to find out we are going to develop our ANOVA table. So it's very important like this. And then we have there for the 2-factor interaction, it depends that if you're looking for the A and B. So look at here for A and B, you would say, okay, so look at, let's see which parts A and B, when you multiply them, they're going to be positive. And when they have the same sign and when they have the negative sign. So when they have the same sign for that screen, you're going to consider it as the, it's going to be diagonal, right? And you would consider it as a positive one, like this. And then you would go, if it's like the negative one, you would consider like the multiplication negative, you would consider the negative one. And then that's for the 2-factor interaction. You would have it for AC and BC as well. But when we have 3-factor interactions, because it would be like curvature, so it's not easy to show it by like just a surface, simple surface. It's not going to be diagonal or the surface on the outside of the outer surface that we would have, or dimension that we would have in our cubic. We would say that the here is that we have the filled dots, like these black ones, and then we have the empty ones as the negative runs. So you will look at all of the positive runs and all of the negative runs, and then you would say, okay, minus, like you would get the difference between them. Okay. So here is the coded version of it. It's like that. We would have the original notation as the temperature, RPM, and catalyst. And then we would have the temperature, RPM, and catalyst in the like negative and positive one. And then the next one is that we try to add the combination of them. Like, for example, I would say, let's say run number 1, if I call it 1, 1, 1, it's negative, right? So when it's negative, we are just going to put 1. When it's positive, we are going to write down the value for it. Like, for example, I would say 1, 1, 1, the combination is going to be 1. So this way is there, like those C, B, A, B, for example, here, we looked at this AC, right? So the way that we can get AC from this table is that you would say, okay, I would have like, probably is this one. When it's positive, I'm going to write down the symbol for it. When it's negative, I'm going to put 1. So it's going to be, and when you combine them, it's going to be AC. So you can see here, we had the AC. Like it was, this means that this is positive. So positive means that it works on the high level, and then we have the low level and then high level of it.